Ladies and gentlemen, I want to welcome you to this week's Build a Complex Model in FreeCAD. Today I want to work on this Model Mania 2001 model. And I will be honest, I have been struggling to meet this challenge. What I mean is, so the idea is to build this model in a CAD software. So this is called phase 1, and then phase 2 comes in action where some of the parameters will be modified. So the challenge is to transition from this phase 1 to phase 2 with minimum changes. So in an ideal scenario, this 64 will be 45 and this 45 will be 55. These are the only two changes that's needed to transition from phase 1 to phase 2. And this is easy to build phase 1, pretty easy, 5 minutes job. And then when it comes to phase 2, the model breaks down. And I've been struggling to do this transition and found out that dependency between two sketches is the main reason of this breaking the model down when trying to transition. So I think making them independent and like minimum number of dependencies between two sketches is the key to solve this problem. So let's get started on this. I want to process the image and calibrate it. And I want to keep it on XY plane. I want to transfer the origin to this point. Alright, and the image processing is done. I'm ready to do the sketching. But before I jump into the sketching thing, I want to make some parameters note down in spreadsheet. So first of all, let me rename this spreadsheet as P. It makes it easy for me to track them later on. So what I want to do is I want to see, so I want to note down some of the parameters. So this part I want to name it as base. So base plate width. So base plate width is 64. So this is base plate, this car width, and so base plate length, back plate curvature. Yeah, that will do. Is 15. I know that we'll be needing that. So back. So I want to keep it side by side and build the sketch. Okay. So let's go ahead and then start working on the sketching. First I want to build this base, and that base is very simple, a rectangle with, this is 20 and the height is 64. It happens to be 64 and I don't think it will be changing, so but we could make this from the spreadsheet. So P, okay, and back, no, base plate width is 64. Okay, so that's our first one. I want to rename this sketch as base plate and make it symmetric. Let's keep it 10 for now. So that's the 10 height. What I want to do is like I want to go there and I want to rename it first. So base plate, and this 10 would be actually a value from the spreadsheet, base plate length. So say P base plate length. Okay, so there it is. That's our base plate, and there is these two tiny holes that I want to take care of them right now before it becomes, you know, a burden later on. So those tiny holes I want to, so since we are working with part workbench, I could go and use the fastener workbench to make them holes as M6. I don't want to go with that trouble right now. I just want to make two holes. So the distance between these two, I'm sure it is 32. I remember from my previous practice. And this is symmetric. The distance between these two is 18. Right? And I want to extrude that by 10 for now, but this is, I'm going to say whole cylinder. Okay, this height would be 20, right? Yeah. So there it is. I want to make a cut. That's our hole. This cut is base plate with hole. A little long name, will do. Right. So one part done. I want to work on this back plate now. So again, minimum reference. With that, I think I can take this reference. It's harmless because that's not something that will be changed. So we took that one, and let's take polyline, draw a line, a curve, and a line here and the line there. We will correct our mistakes from there. It's not a mistake, just the curvature issue. And come here, finish it. So this will be horizontal, okay, and this point will come here. These two will be at right angle. These two will be at right angle too, right? Let's make, okay, let me put down some constraints here. This is 12, it's given here 12, the thickness of the plate. So this will be equal, okay. And what else? Okay, here's the tricky part. This cylinder will come at a 90-degree angle with this line, and that cylinder has couple constraints that we need to do it right now to make this back plate. So the way I want to do it is I want to draw a line on this one. Obviously it will be construction geometry. This is perpendicular to that line, and this length of this line is 32. It's given right here. So we took that, we used that information. Now the distance between these 2 points is given as 146, and I use, okay, there. And the height between these 2 points is 64. It appears that this point is right on this axis. However, in the phase 2 it moves. So I don't want to constrain it on this axis right now. I want to follow their lead and then take this distance, make it 64. Okay, there. now we have only 4 degrees of freedom. These two are at the same center, so that takes down 1. Now we have 3 degrees of freedom. So the angle, the 45-degree angle, is the next one we want to deal with. So this angle is 45. We want to put the formula down here. I want to make it formula. So P, and then the back plate angle, BACK, back plate angle is 45. Okay. So there it is. So 2 more degrees of freedom, which is the radius of this, which is 15. Do we have that on here? Yes, back plate curvature. So this curvature would be, say, P back plate curvature. All right, 1 more degrees of freedom, and that is how far this line would go. Now that one, we can take some hints from here. It says, you can see the distance between this point and the edge of the curve is kind of fixed around here. So from this point to that point is similar as from this point to that point. So this is 60. So from the center, the back plate will go, not 60, 52. So the width is 64. So from the center on this direction, it will be half that the diameter. So I can say the distance between these two would be half that 64. So 64 divided by 2. Okay. Now that 32 is related with this 64, not with this 64. So I don't want to put that on the spreadsheet value. I just want to make it there. So this is 32, and that is related with this 64, the width of the back plate, not this base plate width, this 64. Okay, since we made the distinction, this is a fully constrained. Let's close it, and then I'm gonna say sketch back plate. And I want to extrude that by, you got it, 64, and it will be symmetric. Apply, close. So there it is. That's our back plate. The next thing to do is either of this cylinder or this spline, this reinforcing spline. So let's take care of this cylinder first, because I want to make it this workflow smooth, and having the cylinder built would help us explain things. With that, let's make a sketch on this face. I want to take this line as a reference. So everything will be from the end of the line. So that's our end of the reference, and there will be 2 inner and outer diameter. The outer diameter is 52. So let's make that happen. I want to say P, actually, and then cylinder outer dia. All right, and this will be the inner dia, cylinder inner dia. All right, and how far along this center is from this farthest corner? So that is half the width of this, and which is, so from this point to that point, the distance is half of 64. 64 divided by 2. So that's our cylinder. Now, whatever the reason the angle is 45 becomes, this is always the distance between this edge and the center of this cylinder remains same. With that, I want to rename that as sketch cylinder right, and extrude that. So that would be how far? I guess 32. So that would be 32, but then I want to extend it back by the thickness of that plate is 12. I will explain in a moment why I did that. So now this cylinder extend up to here. Now if I use this one and this one and use this connect join object, what it does is it takes the common thing and then deletes that center hole. It makes it easier, and that's why I wanted to extrude this face all the way to this face, or like even, you know, if it was a little more, say the cylinder, if it was even 15, it would still, as long as it's more than what it is there. All right, now maybe I can use that. So cylinder, and this is the back plate. All right, so and then now start working on this spline thing, this reinforcing spline, and that's where actually the most complexity is. I don't want to use the reference from this sketch more than what I need to do actually. With that, let's start sketching on XY plane, and I want to make this. All right, so let's make it full organic, no referencing. I tried with referencing, and there is always one issue that comes up if there is a reference. So let's say we don't have this back plate there. So we are going full organic. All right, the distance between these 2 points, the vertically it is 12 and horizontally it is 20. So that's one fixed point. The distance between these 2 points is 64. It doesn't change, right? The radius of this curve is 55, right? This radius, now we don't know, but is it true that we don't know? We can calculate. So this is 15. Actually these two will be at the same point. Okay, so this radius was 15 and there is this distance between, the vertical distance is 12, so this radius must be 15 plus 12. Simple. Okay, so that gives us this line. I want to make them perpendicular and these two as perpendicular. Now we have 4 degrees of freedom. One of them is being the height of this, the length of this line, which is 26 given, so that was easy, right? 3 more degrees of freedom. One of them is actually this is, so the angle between these two, which is 45 or 180 minus 45, right? So this is the line that we measured 45. So what I can do is I can actually make an angle between this and make it a formula from our spreadsheet and say make it back plate angle. All right, so that constrains another degrees of freedom. Okay, 45 there. Now what else? How far this line would go? That's another question. Anyway, what I can do is I can draw these 2 construction lines, these 2 construction geometries, right? it won't be on that curve. I want to make it free. Okay, I want to make them perpendicular. This 26 is bothering me right there. I actually want to bring it here. 26. Okay, so these two, and I want to make these two collinear or parallel. That didn't play good, right? Why? I want to make them collinear. Okay, can I not make, or say tangent? Yeah, that's more like it. So what it is now is, between these 2 points, the distance is 146. So 146, which remains the same between phase 1 and 2, so no need to make that a formula. This distance actually changes. So this is that the datum, the backplate datum. So I want to make that as P backplate datum. Now I just remember, did I do that in our connect? I did not. Okay, so backplate datum. Okay, yeah, thank God I remembered that, otherwise. Okay, so now we got the height, the length of this line is 32. It always stays the same, 32. Cylinder height, did I have cylinder height? No. Okay, one more degrees of freedom, which is how far this thing goes. How far this thing goes is a question. It should go up right there on this line. But think about it, if I extrude it on both sides, because this point is the farthest point of the cylinder, there will be gap between these two objects. I want to make some overlap. I want to keep it right there. So this point would be actually between these two, or like this line would be half the diameter of the outside, half the diameter of 52 minus some overlap. So what I want to do is I want to make that, say, take that and make it cylinder outer dia, okay, divide by 2 minus, I may say 4 millimeter of overlap. I want to do that. Okay, that constrains the whole thing, and let's pray that it will work. I want to rename that as sketch reinforcing or sketch spline, C-spline. I hope that's appropriate. And I want to, you will notice that the thickness of this one is not given. So I'm only guessing it will be 12. And it will be symmetric. Apply, close, good. There. So that's our object. We have 3 parts, base plate with the screw, and there is this back plate with this one, and this is this spline, S-P-L-I-N-E. I want to make, now you'll notice that there is this corner I have not cut yet. I want to leave that for later. I plan to actually make that as a fillet, and in FreeCAD it is best to do the filleting at the end of the cycle. So I want to leave it right now and then make all of them a union, right? And say this is our phase 1. So let's save it. So I saved that. before I call that as phase 1, let's actually make that curvature, and this will be 32 radius because it will be a half circle. The entire the length is 64 divided by 2 is 32. I want to go 31.99. Okay, so that's our phase 1. So this is our phase 1. We saved it. What I want to do is I want to transition from phase 1 to phase 2. And before I do that, I want to delete the fillet because I really don't want to take any chances with fillet. So let's save this as phase. So I saved, so we have a phase 1 backup if something goes to south. And now let's delete this. Okay, we will work on it. On phase 2, you will notice, so this is phase 1, we already finished that was complete. Phase 2, the angle becomes 55 and the height between this point and the base point becomes 45. So this becomes 45 and this angle becomes 55. Something did not work out good. Oh no, this is 64. See, this is confusing. The datum becomes 45. See there. Ah, dang. So this will change, and I'm going to say this will change. So between phase 1 and phase 2, so this, again, this was 45 and this was 64, right? So this was phase 1. This was phase 1. This is with the curvature. So it was 31.99 and there. This is phase 1 complete. Now I want to transition to phase 2. I know that filleting is an issue in FreeCAD, so we as FreeCAD users, we decided to live with it as long as somebody comes and then solves this issue, being patient with that. To go to phase 2, what I want to do is I want to delete the fillet and then change this angle to 55. This datum becomes 45. There. That's our phase 2. Well, let's do the filleting now. So it becomes like a complete 31.99. There. So this is our phase 2 completed. As you can see from this picture on the side, on the right side, it does match with our phase 2 picture and all the parametric. So FreeCAD, being a free full parametric software available to us, what supposed to be a full commercial software product in SolidWorks, with this limited skill that I earned over the last couple months, I was able to do this challenge. Maybe it took me like a couple more minutes, but it's possible in FreeCAD, and that's all we wanted to get out of FreeCAD. Hopefully you enjoyed this process. On the next video, I'll try to take on the Model Mania 2002 challenge in this channel. So until then, stay safe and take care.